All right, let me start sharing my screen. If all goes well, everybody should see my screen now. Could you confirm
Yes,
this?
we do.
Okay,
Yes,
great.
we do.
Okay, great. So my name is Ken van Kampenhout, and today I'm responsible for technical enablement within the Aruba Benelux organization. I'm within Aruba, or let's say HP, HPE Aruba, for over 10 years now in various roles. As Gert introduced, we're going to talk today about Aruba ESP. And indeed, it is not a product. It's also not a management platform. It's an architecture. So this means that there is no specific SKU or no specific product you can buy and say, we have implemented Aruba ESP. This presentation is actually a guidance how you could evolve towards a complete implementation of the Aruba ESP architecture. And we do this by explaining the transformation, let's say, in 3 steps. So some more introduction. In the past, we've architected our networks to support a cloud-centric compute model. But the cloud is in essence nothing more than a big, heavily automated data center that brings together compute, storage, networking, resources in order to provide a platform for applications. So this era, let's say, was known as the cloud and mobility era, and most networks today are still architected in order to support this model. But unlike the cloud, the edge is the exact opposite. The edge is distributed and is in all places where we work, live, play even, however you want to say this. So the edge is also the result today of the growth in IoT and operational technology devices and their generated data actually. Now, to convert this edge-generated data into value, it is necessary that a lot of this data stays at the edge. Why? Because it's often too expensive or simply non-compliant to backhaul actually or to send this edge-generated data to the cloud. In a lot of cases, even when we are allowed to do this, and we would do this, then simply it would be too slow to send the data to the cloud, process it in the cloud, send the action back to the edge, and enforce the action in the edge. So this means we need to evolve to something which is called the intelligent edge, where we have both edge, let's say, processed data and cloud processing. So the cloud or a centralized data center is still needed to capitalize on the edge data and on the opportunities. So the edge always is going to connect to the cloud. It does not live by itself. It has some autonomy, but it's not completely autonomous. In order to make the intelligent edge effective, this means we need to fall back on the cloud. So we need to rethink our networks in a way that we work from the edge to the cloud. Of course, there are still some challenges that exist today in current networks. For instance, a lot of networks are engineered in silos. We have a silo which is, for instance, data center networking, another silo, campus networking, another silo, SD-WAN, another silo, Wi-Fi, and all these silos, in a lot of organizations, they are implemented using another vendor, another technology, another management platform, which leads, of course, to a lot of fragmentation and to the use of multiple management tools within the organization. Another challenge we still see today is that a lot of the troubleshooting and the actions done in the networking world are still completely manual. To give you an idea, for most network administrators, if there's an issue, first reflex is to make sure they can still run Wireshark or some kind of tool to, let's say, capture Wi-Fi signals and do deep down analysis. There is no real, let's say, easy way to troubleshoot networks for most administrators. Most of them use old tools like Wireshark, network mapping, and things like that. Yet another issue, and this is also largely triggered by this growth of IoT and OT technology, is that a lot of the security threats are no longer from the external side of the company, but are originating from within the company. Most of the IT staff, let's say, don't have a clear view on everything which is connected on their network by the business or the operational people, let's say. And then, of course, a last challenge, but certainly not least, is the resource constraints, of course, that exist and that even are, let's say, more stringent due to the COVID-19 pandemic. Of course, it has had an impact on everybody's budgets. So basically, we say networks must do more. We must break down those silos and create unified tooling and a unified architecture in order to solve these problems. So when we rolled out the mobile first architecture, the Aruba ESP is actually a new view on how we see the network. It's the industry's first AI-powered cloud-native platform designed to automate, unify, and protect the edge. So within ESP, we have 4 core attributes. We have AI Ops, which actually gives the network its sixth sense. So this is where all the artificial intelligence and machine learning algorithms reside. Then we have a zero trust security layer. This is basically the policy layer of our network, where we try to automate as much as possible the segmentation in the network in order to support the connectivity of all these various IT, OT, but also human interaction devices. And then we have a unified infrastructure layer, where we, of course, try to break down all of the silos. Last but not least, most of the things within our model, or practically everything in our model, can be consumed in an as-a-service model. So this means, it's a pure, let's say, management subscription-based platform on one side. On the other side, we could do the complete as-a-service package with GreenLake for Aruba, for instance, or in collaboration with one of our partners, Quant, for instance. So how do we see all these different things? The infrastructure layer, of course, is where the real hardware resides. And we see there the different wireless wire technology, SD branch, SD-WAN. 5G offloading is also a possibility, and IoT support technology, let's say. Then we have the zero trust security layer, which, as I said earlier, is mainly the software-defined policy layer, where we basically implement dynamic segmentation, for those of you who are familiar with our wording. And then on top, we have the AI Ops layer, when we run actually all the value-add services, like the onboarding, zero-touch provisioning, location-based services, management of the infrastructure. So all of these are in the top layer. And then we have the 3 steps, as I explained earlier, on which the presentation is going to be built. Step 1 is we talk about the connect layer, which sorts of infrastructure make part of the Aruba ESP. Secondly, the software-defined policy layer. How can we define the policying? And third, the services layer. So let's continue. Step 1, connect. What about the unified infrastructure layer? So for many years, users and their devices have been connecting on access points only using the Wi-Fi technology. However, nowadays we see that IoT needs to connect to the same access points as well. But IoT is not always connecting through Wi-Fi. And actually, in reality, there are about 300 different sorts of wireless technologies which are used by IoT devices to connect to the network. So with our Wi-Fi 6, so the AX standard access points, we actually want to evolve from just a Wi-Fi connectivity platform to an IoT connectivity platform. And so we want to offer other technologies as well. So all of our Wi-Fi 6 antennas have BLE and ZigBee support. It's actually an 802.15.4. What's in the name? It's an IEEE standard for the radio that supports, amongst other things, ZigBee. So how does this work? We use this additional radio in order to capture signals which are in the edge. For instance, in a hotel, it could be communication from the door box. We capture those signals and we hand them over to the management platform of the IoT vendor. We have specific partnerships in that area, of course. Same thing, more or less, is the case for BLE, but BLE has been around and has been, is a bit better known by now. So that's the idea behind the AP as a, let's say, IoT connection platform. Another thing is that we have also dramatically simplified our Wi-Fi architecture. For many years, our IT organizations have been forced to choose different architectures for campus versus their branch or even the remote worker access points. So typically this would mean that there would be a controller-based WLAN architecture in the campus and maybe some controller-less architectures in the branch or for the remote workers. So typically this creates, again, silos, different architectures, different management platforms, and so on. So with the evolution of Aruba ESP and in the intelligent edge area, we want to lose as much complexity as possible. And because it's actually most of the time responsible for delays, errors, downtime, the less complexity we have, the less chance that something could go wrong. So we decided to unify our Wi-Fi portfolio into one single software architecture for campus, branch, and remote workers. It's named Aruba OS 10. And all of these can be managed from one location, so from Aruba Central. So in this way, we lose all the complexity and we break down the silos in the Wi-Fi architecture. So next, on the connectivity layer, same thing more or less applies for switching. A lot of organizations have had different switching architectures for their data center and for the wiring closet. Same thing more or less applies over here with AOS 6-based switching. We want again to resolve the issue of having multiple switch architectures on a network, let's say. AOS-CX or AOS-CX portfolio actually spans from the small 12-port fanless switches until the high-end, let's say, chassis, fridge-sized data center port switches. So all of these exist, and we have some specific features. We have non-stop power over Ethernet. We have one management tooling set. We have live upgrades. And of course, it also means if there's only one operating system throughout the switching portfolio, that it's only one way of doing things. So you need to, you have the possibility to reduce on training as well. Next step after doing the simplification in wireless and wired networks is to also unify the connectivity of the edge of the branches. Today, most organizations connect through the cloud using a combination of different technologies. There is still MPLS around. There is also classic broadband internet or mobile networks. 4G, 5G backup connectivity is also out there. So managing the connectivity across all these links towards the applications can be quite complex and time-consuming. So from the same architecture as we use for Wi-Fi, we've actually enabled our gateways to also do SD-WAN connectivity in order to balance the load across different links that are there available and to select the link, let's say, that is most optimized to connect to a certain application. Of course, this is a very short introduction, but I think we all get the idea, let's say. So let's summarize the connect layer. So as I said, we're evolving towards the IoT connectivity platform with a single architecture for Wi-Fi, both campus, branch, also remote workers. We're unifying the switching side by having AOS6, which spans from the smallest wiring closet to the high-end data center core switches. And we're unifying branch connectivity and using the same methodology over there with our SD-WAN portfolio. But in order to facilitate state-of-the-art management tooling, we still need to rely on the cloud. According to Gartner, only 15% of all organizations are using cloud management today. And this is expected to grow, I believe, to 50% by 2025. So unifying the operations in the cloud allows us to eliminate all those siloed management tools. We can create one management tool. It also offers us the possibility to enable new as-a-service and on-demand consumption models. Another benefit, of course, is that there is also the resiliency and the massive scale-out compute power from the cloud. This scale-out compute power enables us to, let's say, incorporate artificial intelligence and AI components. So artificial intelligence and machine learning components in our management tooling. So this is a summarization from the connect layer. Let's continue towards the protection layer. So this is actually where we implement our dynamic segmentation strategy. So what's zero trust security? Zero trust security actually means that there is nothing trusted by default. So whether the connectivity is coming from inside or outside the network, there is always a complete verification required before gaining access to resources on the network. So if you're familiar with security, you're probably also familiar with the acronym AAA. So it continues to serve actually as the foundation, let's say, for security, even in this era of the intelligent edge. But there is only one exception. We would like to rename the last A from accounting to access control. Why? Because accounting is about tracking who accessed which services and when. But today, devices can even be compromised after they've gained access to the network. So it's important to continuously check the access control and to really limit the amount of resources that can be accessed. Let's talk about this in a little bit more detail. So on the protection layer, it's best to use the highest method of authentication where possible. So that includes using encrypted tunnels wherever possible, using as much .1x based authentication where possible, possibly multi-factor authentication, use profiling of devices, and stuff like that. So all of this works fine when the device is intelligent enough or when there is a person behind the device which is capable of responding to the multi-factor authentication. But many IoT and OT devices, of course, are not intelligent enough to speak .1x. They are headless, so there is also no human behind the keyboard to react to the multi-factor authentication parameters, let's say. So a lot of organizations are still relying on SNMP, network mappers, or possibly WMI to determine what the device is and what it's actually doing, let's say. But all those methods only provide static information, things like the operating system, for instance. In order to, let's say, secure this new environment, we need more details. So this is why we developed ClearPass Device Insight. ClearPath Device Insight actually uses artificial intelligence and machine learning algorithms to understand what a specific device is and to group similar devices together into one signature. Once you have captured that information, we're able to share that information also with ClearPath Policy Manager, where you can, of course, implement a policy based on the signature discovered by ClearPath Device Insight. So ClearPath Device Insight does a lot more than just looking at those static parameters. It also looks at the sort of protocols your edge device uses to communicate, the frequency it uses to communicate, to what resources it would like to access. All of this is captured using deep packet inspection. So when we continue, once the device has been authenticated, we actually need to authorize the resources to which it has access. Most of the organizations today do this using static configurations like VLANs, subnetting, and centrally enforced ACLs. But in this new era of IoT, let's say, and OT, this will no longer be a valid solution. Why is that? Because those static configurations will no longer be sufficient. There's just too many different types of devices, and for each different type of device, we would need to create a new VLAN, we would need to adopt or update the ACLs. So this is a very painful, time-consuming, and error-prone process. So clearly, there's a large benefit in automating this. And that's actually what we want to do by implementing dynamic segmentation. The goal here is clearly to eliminate as much of those static configurations as possible, delivering the highest protection levels available. So we would like to simplify the segmentation of traffic by understanding first what the device is and what kind of, let's say, resources it needs to access. All of that information we put into the ClearPath Policy Manager, which is actually our centralized, let's say, policy database, more or less. So in this case, the policy manager is going to communicate the set of rules that a device can or needs to comply to a gateway. And it's that gateway that is going to enforce this rule base to the client, whether the client is connected wireless or wired. And by doing this, we can really limit down the access, let's say, of a specific client, and we can really dynamically reconfigure the network. So, of course, there are quite some benefits over here. First is that we can enable consistent policy deployment for wired and wireless. Secondly, we eliminate those static error-prone configurations. And third, we enforce or we improve the protection level by, of course, using the deep packet inspection, which is available on our policy enforcement firewall. So the security threats, of course, don't only arise from the IoT and OT devices. There's also the internet, which makes remote offices and branch offices increasingly vulnerable, let's say. So Aruba and Silver Peak, of course, as well. We have taken actions to secure those cloud-based threats, let's say, those threats from the internet. For instance, we have IDS IPS functionality available in our SD branch portfolio. It does not only do simple north-south security, so traffic coming from the internet to the branch, but we also, and that's quite a unique capability, secure the east-west traffic, so the traffic within the branch. Another interesting thing to know is that we have also integrations with well-known third parties like Zscaler, Checkpoint, Palo Alto for their cloud security platforms, let's say. So with that, we proceed to step 3. Step 3, the analyze and act block, let's say, of this journey. So again, according to Gartner, about 55% of the network operations are still manual, and only 5% of the organizations are using, let's say, artificial intelligence or machine learning algorithms to, let's say, augment the network operations. This clearly means that the network is still bound by human scale. Humans are still needed to detect the error, diagnose it, and resolve it. Unfortunately, people can get sick today. They need time off to get a vaccine. Let's hope we get it quick. And sometimes even people make mistakes. It happens. So this is why artificial intelligence and automation can clearly play a much bigger role, let's say, on the network management layer. As Aruba, we have, let's say, created AI Ops, which is actually the naming for our artificial intelligence layer within Aruba Central. So make no mistake, the AI Ops is relying on Aruba Central, where we exploit the massive compute power of the cloud architecture, say it that way. AI Ops actually has 3 big building blocks. It has AI Assist, which is coming soon. It has AI Search, which is basically a natural language processing engine. So you could type natural language, unfortunately today in English only, in the search bar of Central. For instance, you could type, where can I find client Ken's laptop? And then it will immediately guide me to a page where I can see that my laptop is connected to my access point, uplink to that switch, to that gateway, and that connectivity towards the cloud. And third, and certainly not least, is AI Insights. AI Insights actually, helps you diagnosing, let's say, issues, and helps you create optimizations in your infrastructure. I think actually Steven is going to go in a lot deeper in AI Insights during the demonstration. So with these 3 features, we actually want to do 3 things. We want to react and resolve issues a lot faster. Our goal is really to solve the issue before it has a business impact. We also want to continuously increase the capacity inside the network. I have an example for that inside the slide deck, where we create a capacity increase without adding additional hardware. And most important, we try to identify specific root causes and give some recommendations and so on. And we have achieved an accuracy rate of over 95% in that area. So I have a small detail slide in the deck for AI Assist. It's coming soon. I believe it's coming this summer in the next central major release. So what's the idea behind it? The idea behind it is that we have let's say, some sort of recipe, like when you're cooking. So there's a certain event being noticed in Central, then the recipe gets triggered and the system already is going to do log collection, let's say, some packet capturing, and actually groups all that data together, ready to be sent to Aruba TAC. So it actually significantly releases or reduces the burden for the network administrator, let's say. Then AI Ops. As I said earlier, I think Steven is going to go deeper into this in the demonstration, but I still want to give an example. So a quick example over here is that it would normally take an administrator hours or possibly even days, in order to set the correct, let's say, maximum transmit levels and stuff like that for radios. With AI Insights, we actually, based on of course, the information we capture from the access point and the artificial intelligence algorithm, we will actually give you what we think that is the ideal threshold in order to configure the radios. Yeah, I would like to go a little bit quicker over here than, because I think it's also coming in Steven's demonstration. So in the interest of time, I'm going to go to another example, which is a passers-by problem. So basically, this is a problem being detected at a retail chain where we see that a lot of outdoor passers-by are polling continuously for wireless networks. Of course, the wireless network need to respond to that polling, and this occupies, let's say, transmit time and stuff like that of the network. So it actually drags down the network performance. So what did we do? Based on, again, artificial intelligence and signal to noise, based again on artificial intelligence and machine learning algorithms and peer benchmarking, we suggest to change the signal to noise probe thresholds in order to, let's say, eliminate or to avoid that the system is going to respond to those probe requests from the people outside of the store. In this way, of course, there's a strong reduction in those users which are polling, which creates, of course, new transmit time for the network inside the store. And in this way, we succeeded in creating 25% of increased capacity without adding hardware. So, as I said, it's done using peer benchmarking. Yeah, I think I explained everything already on this slide. So as a summary, before I hand over to Steven, so what is Aruba ESP? It's all about the intelligent edge. And we want to enable the edge. We want to capitalize on the data generated at the edge. It's all being managed, and all the artificial intelligence is part of Aruba Central, which is our cloud native, let's say, management power, ready to provide those intelligent insights. Basically, there are 3 steps to evolve towards a complete ESP architecture. We work on the connection layer, which is the unified infrastructure layer, a lot of simplification over there. Protect the environment using dynamic segmentation. And third, and certainly not last, we use artificial intelligence to analyze and act on the environment. So this as a summary for my part of the presentation, and then I would like to give the word and the share to Steven de Metz, who's going to present you a little bit more on Aruba Central.
Yes. Thank you, Ken.
Let me stop my share. I think it's yours, Steven.
Thank you very much. There we go. I hope this is visible to everybody.
It is, Steven. We can see it.
Okay.
Yes, it is.
So, welcome to Aruba Central. I made myself a customer, and I'm the customer. I'm called Quant Demo, and I have 4 sites. The place where Gert lives, the place where I live, our office, and the place where my colleague Kurt lives. Now, we all have an access point in our house, and at the office there's a switch. Unfortunately, it's not an Aruba OSCX switch, so I'm not going to be able to show you a lot. Just the fact that it's there and that there are clients attached to it. Now, before I go further into the devices, as you can see here, we have instant access points and a switch. I just want to show you how easy it is to get these things installed. So we have created a site for every site we have in our demo customer, and we have an installer so somebody who will actually install these devices, and we can then assign an installer to a site. And when this person goes on site with a new access point, he can then connect that access point to the network and use an app on his smartphone to scan the serial number of the access point. It will be automatically added to the appropriate site and receive its configuration. And that's how easy installing new access points in new sites works. If it's an access point in an existing site, the normal adding to the cluster and so on, or adding to the controller methodology still works, of course. And then here you can set the status of the installation of certain sites. That was just a short introduction on how easy Aruba Central makes installing a site. Certainly, if you just give it to like some custodial person or an electrician who has no or limited knowledge about IT in general or networking in general. Anyway, back to our overview. So as you can see, since for the sites I had to give in the address of where the site is, all the sites are nicely shown on the map. And when everything goes well, the site is green. And if something goes wrong, the site is red. Now here, the site is red because the devices is offline. So the device here is red, which means offline. We also have an AI insight, which is just on a warning level, and no clients, of course, because there's no devices, which is normal. If we look at another site, we have one active device, one active client, and no AI insights, which means everything's good. Now, some of you might have been present when we could still come together all together in a nice place and have a drink and some food and a chat and shake hands and maybe even hug and stuff like that. You know, back in 100 years ago, we did a session about user experience insights. I've installed one of those sensors, used to be Cape networks. I've installed one of these sensors at my place, and then I've integrated the user experience insight with Aruba Central. So for my site, I get the little smiley face that everything is good. And then when I click on this, it will actually open the user experience insights and show me that, hey, you've got two sensors and all the Wi-Fi is good, the HTTP, everything's good. You can get your internal NAS and you can get your external services that you need every day. So everything's okay and everything is good. Now, the fun thing about this is that one sensor measures my own Wi-Fi, my home Wi-Fi, and one sensor my work Wi-Fi, well, the demo work Wi-Fi. And so only one sensor shows up here. So if I do something that makes this one go bad, it won't change here because it's not measuring something that is managed by Central. So the system is intelligent enough to look at which errors to count and which not. Because as you can see here, I'm on my home group. If I take all groups, we can see that there's a lot of problems because the other sensors aren't online, but they're still configured. And since I'm only interested in this one, Aruba Central knows that and says that everything is good. Just as a little side note, that took me way too much time. We can go into the devices and see what's happening there. So we have one offline, two online, one offline. And we have a switch, which is online. And then we can have a look at our clients. There we go. Now, this is data from a week. And we can see that there are clients not connected anymore. For instance, Kurt's telephone is no longer connected to the demo SSID. Kurt, if I may ask you to connect it, if possible, of course, to connect it to that SSID,
Yep.
then we can see during the demo that it comes online and stuff like that. Nothing too mind-boggling or weird. You also see the difference between Wi-Fi connected systems and switched connected systems. This is just a Raspberry Pi running Linux, doing some stuff just to generate some traffic. And since it has a fixed IP address, I think that's the reason, because no DHCP traffic passed, so it couldn't sniff that. I don't know. As I said, it's not an Aruba CX switch, so the implementation is limited, unfortunately. I can't show you anything about guests because we're not doing guests on our demo network.
I just connected it, Steve.
Cool, thank you. We'll see it come up in a moment. We can also have a look at the applications, so we can see what the applications are that have been most used on our network combined, because I'm in the global, the Aruba demo, which comprises all 4 sites. So I see information here for the 4 sites. If, for instance, I just want to see what I've been doing at my place, there we go. There's quite a bit of YouTube. What else can we have a look at? Microsoft SharePoint, OneDrive and Teams. So yeah, Skype, which is weird because it's probably Teams now. Netflix, of course, because, you know, what else do you do when you work at home? I need to say these numbers are because of the sensor, because as you can see, it constantly looks at YouTube, it constantly looks at Netflix, it constantly looks at Amazon Prime Video. So that's why those numbers are so high. I have a Telenet subscription at home, and there you can look at the telemeter, and if I keep my sensors on, both of them, I generate about 1.2 terabytes of traffic every month. Telenet loves me. Security, well, there's not a lot here because I'm doing WPA3 and I have not enabled rogue detection. It's a feature that we had to go through Aruba support to enable, and I haven't had the time to do that yet. And as I said, guests, there are none. So let's go back to the global listings. There we go. And back to our network health, where we see what happened. Now we see also that there are 2 clients at Kurt's place, because he just told us he connected his phone. One Health, I'm not testing SD branch, SD1, so I can't show you anything there. But here we have the summary. And again, this is for everything. Yeah? And we can see all the traffic for the different SSIDs that we have, inbound and outbound every time. Client count on the networks, and then top APs by usage, top clients, and so on and so forth. Also here we see that there's only 2 WLANs shown here, and that's because one device is offline, the one from Gert. So it isn't shown here because it's not active. Wi-Fi connectivity. This gives a general overview of how's my Wi-Fi doing, and are there any issues that are happening now and that are important enough to mention here. So we can see the AI insights, as Ken mentioned. There's some DHCP problems, and there's a DNS that's failing a lot. So we can see that here. The experience for DNS is still 94% good. And that's because for 640,000 requests in the last week, only 41,000 failed. So that's less than 10%. So that's fine. Okay. then yeah, the problems in a little more detail. You have to imagine this with a network of dozens or maybe even hundreds of APs. This will become much more relevant to have a quick overview of potential issues with your network. Okay. If we go to AI Insights, we can see a couple of things here. I'll put it on a month so we see everything. There's one issue here that says that there's clients connected at low signal to noise, and it thinks that are outdoor clients, which it are not. But I think that is because I'm connected to the AP indoors. I have my iPhone in my pocket and I leave home. At a certain point, I get a low SNR and I disconnect. I think that may be the issue. Should need more study. Everything is clickable. So outdoor clients, and then it gives me the list. So that's quite nice, actually. Access points with a high number of reboots. Now, I've been playing around with configurations and rebooting and restarting access points. This is what it shows. Why is this gone? What happened? Let me try again. That was weird. I think I pushed the back button or something on the mouse. So it gives me the issue for 2 access points. Now, this one, that's me, my access point, that's normal. And then we have the one from Kurt, that's normal as well, because he moved houses and took his access point with him. Yeah.
Several houses.
Yeah, and so even this is captured, and they raise a question about, look, you have an excessive amount of reboots on certain access points. Check it out. Now I checked it out. It's normal because we moved. This one is really nice, and that's the one that Ken mentioned in his presentation, where the transmission setting, the transmission power of certain APs isn't what it should be. And what it says is that dual band capable clients are primarily using the 2.4 gigahertz band and not the 5 gigahertz band. And basically it's because the 2.4 gigahertz radio transmit power is too high. The how you call it, the best practice is to put 5 gig signal 6 dBm higher than the 2.4 gig signal, and since you want 5 at maximum, you have to lower the 2.4. Basically, that's what this means. And yeah, it says the same here again. So either we need to enable band steering, or we need to. So these are nice. This is actually useful information where you can now go into the configuration of your devices or the controllers of the devices and change a few settings, implement them, and then see in AI Insights what happens, if this still continues to happen or if this gets better. And we see that all 3 sites were impacted, so all 3 access points, and 3 clients actually have that problem. And if you look, we are using Dell laptops, and they all have the same issue. So I'm not thinking it's only the Aruba wireless. It might be the laptops too, because the iPhones and other stuff, I have a MacBook here, they don't have that issue. So, meh. Yeah, clients had significant number of low SNR minutes, also quite normal, because of course I only installed 1 AP in every house, or well, I didn't install them, but I only gave 1 AP to every person, and that is somewhere in the house. And if you take your phone with you, and if you look at the clients, if you take your phone or your laptop with you or whatever, the signal will go lower and you will have issues. So yeah, Then the next one, DHCP server connection problems. Ooh, 3 sites impacted, 1 server impacted, 3 clients. Let's see. Yeah, some clients here don't even have a name. Kurt's phone had an issue again. And basically, either there was an offer timeout or a request timeout. Now, these are DHCP servers integrated in either a Telenet router or a bbox or something like that. So they're not industry or enterprise grade DHCP servers, which makes it kind of okay to have these issues of slow responses or timeouts, because the clients will try again, and once you got your IP address, it's fine, it'll just keep working. So not something to lie awake about. If this happens on an enterprise network, then of course, yeah, you need to have a look at it. And then DNS server with a high number of rejected queries, and there's all kinds of different things here. We got function not implemented, server failed to complete DNS requests, domain name does not exist, and the biggest one, well, they're both big ones, the server refused to answer for the query. Now, these two, they are mine. I know that's on my side with my DNS server, because I use a DNS server that doesn't reply to domain requests of known ad servers. So that's why they refuse to answer. If I go to ad click or something like that, it doesn't answer. So I don't get the ads in the websites that I visit. And then domain name does not exist. That's kind of normal again, because we're using instant access points just connected to the internet, not to the corporate network. And I did not build VPN to go to our corporate network. So we rely on the VIA client from Aruba on our laptops to do all the VPNing. And sometimes it doesn't connect immediately, and we have to do it manually. And in the meantime, all the Quant ICT.local domain requests for all the local network services that we use don't get a response because they're a .local. So yeah, that's that explained. But still, it shows you what the impact can be of misconfiguration or actually trying to prevent ads getting into a browser. I mean, that's half of my DNS requests that do not get answered by the DNS server. Half. That means half of my web requests are ads or malware or whatever. There's a lot more than just ads that gets blocked by these servers. It's amazing how much of these requests needed to be filtered. And that's the AI insights for this network. Now, I can go in a little bit of detail. For instance, if I go to my site, I can start configuring. So I have configured here. It's this is my SSID. It's a WPA3 protection, just a shared key. And I can do everything that you could do if you go directly onto the VC and start configuring there. So, I can play with the whole radio management. I can set up the system to do specific things. Just needed to load a bit. There we go. So, I'm connected to VC Steven, and we've got some settings here, all normal things. And then now I can see the clients only on my VC. And we see that we have a failed one. This is because it's just not connected to my network anymore. and it was misconfigured when I did try to connect it on the 28th of January. So yeah, so 2 weeks ago. And it was because I had put it downstairs and tried to connect here upstairs, and the quality was so bad that even the DHCP request didn't go through. So yeah, that's one of those sensors, the sensor that doesn't measure the office Wi-Fi. Now, we also saw in the presentation from Ken that there was something like AI search, and that's here, AI search. And here I can go like configure something, and then it goes into the help, and you can configuring access policies, and here we go. And then it gives me all kinds of things that I can read about it, and I can also just go to the view to get into the AP security page and start configuring. So that's the intelligent search. Now, what the intelligent search also does is search my data. So I type in phone because I know that's the name of Kurt's phone that he just attached to the network. And I can immediately see that it's a client, it's phone, it's connected wirelessly in the group Aruba demo, and then I can click on it and it will actually go to that phone. And it will tell me it's connected here on that IAP with all the possible information that it has. And then we can see it's been on and off in the last weeks. And we can then go to AI insights just for that phone, and oh look, he has a DHCP issue and he had a low SNR, which maybe is normal because you put your phone in your pocket and you leave your house. So location, where is it? And then normally it should show the map and the okay. Weird. And then sessions, this is what it is doing right now. Okay, good. Okay, you're not doing anything. No, okay. Good, you're fine. You're safe. And then we can, of course, look at the app RF. And you see, typical for iOS devices is that they try to update. And yeah, apparently SoundCloud is a thing on this device, and so on and so forth, iTunes and whatever. Live events, I don't know if there are any. Blah, blah, blah. Oh yeah, it's troubleshooting right now. It'll take 15 minutes. I'll just leave it running and then maybe we can come back if, no, I don't think we're already over time. So this is basically what Central can do for you. And if you have known Central from a couple of years ago, a lot has changed in a good sense. Certainly the AI insights are worth their weight in gold, basically, because a lot of things are fine. They're there. I don't care too much about them. A lot of things like the dual band capable devices that do not want to switch over. This is interesting information. You know, the DHCP has an issue that's good to have a look at and see what's going on and try to remedy that. So it basically gives you a better starting point to troubleshoot issues on your network. So this is where I'm going to leave it. I will hand it back to either, I think Gert, yes. And if there's any questions, I think now's the time.
Thank you, Steven. I've seen in the chat that there are not so many questions. There was one, but it was solved during the session, so it's quite easy. Are there any other questions from the persons that are now attending? Please say something. Customers, prospects, people of Quant? Was Ken that clear? And did Steven explain it?
Hello. I see one question from Kurt in the chat. He's asking when Aruba OS 10 will be released.
I see it, yeah.
So actually, we expect to go general available this summer with the next major release of Aruba Central, but it's already active for, I think it's more than a year now, but it's a specific feature today that needs whitelisting on Aruba Central. Unfortunately, this is not an AOS 10 update session, but AOS 10 relies on Aruba Central for quite some artificial intelligence. So those two are really tied together.
Someone else with a question or something to add? Okay, normally I should say let's have a drink. Unfortunately, today it's not possible, but I hope in the near future we can do some events with physical presence, but we will see. So I would say thank you for taking some time to be with us on a virtual way, and hopefully we see each other next time. Thank you, everyone.
Thank you.
Thank you.
Thank you.
Thank you, Ken.
Thank you. Bye.